his talk was back up to the slides. Well, some years ago, 2010, David Winter blackmailed me into writing a chapter in the one of many handbooks on personal construct theory, and I had to write about assessment from an overall perspective. And since my specialty was the repertory grids, I started to ask myself the question, why do we use them? All keyboards are different. So I thought I'd go back to the basics, just to make David Winter happy, So I read chapter 4 about Kelly's clinical requirements. He said for a test, but what he meant was an assessment tool, because in the 1950s we called everything a test. And he had these 5 requirements for it. And it looks pretty comprehensive, because no doubt he was a good clinician. So, define the problem, reveal the pathways and channels, that sounds familiar to the theorists. Furnish the therapist with clinical hypotheses, reveal resources, and reveal problems that you might otherwise overlook. Well, it turned out that Kelly saw the repertory grid as only being having one function, to furnish the therapist with testable clinical hypotheses. And that explained to me a lot about the really dug grid that Kelly has in his book that nobody talks about. Oh, they talk about the book, but not the grid. Because the grid is what most people now would consider defective. For example, it has 3 constructs, female, not female. And of course, for Kelly, and he writes this in the text, what he was interested in was, I must ask the client about this, They're using it in different ways, because they weren't arrayed the same, because sometimes it meant, older females, and sometimes I'm supposed to stand on this side, it seems. Okay, so what Kelly saw it as was, now I'm in your way.
No, don't worry.
Kelly saw it as providing questions, just as most non-questionnaire personality measures do. TATs and Rorschachs and things like that, and sentence completion and that. It gives you material to go take back to the client. But we now see it as providing answers. What can I learn from the grid? Never mind about the person wherever they are. All I'm interested. They've given me this raw material, and I'll do something with it. Well, how do grids provide answers? Well, mostly we analyse the data of a grid. Sometimes it gives us a number, cognitive complexity, dylematic constructs, self-ideal discrepancy. We can get a number that we can come to an conclusion that yes, they've got a big self-ideal discrepancy. I'm pretty sure they'll be depressed. And sometimes it's a picture. And that's where I've been involved most with kind of principal component plots. Because when I came to England for the first time in 1979, I found that everybody thought that Patrick Slater pulled some fancy trick to get factor loadings for both constructs and elements. And it's a view that's still around today. I could take you to a website about the analysis of grids that says that was what was wrong with what Slater did. Well, what Slater did was operationalise a theorem in 1936, Psychometrica, which was the approximation of a data matrix by one of lower rank. It didn't sound like it was going to turn into Ingrid, but that's what it was. So the other one is hierarchical clustering, which I know about because I have to teach it the rest of my life. Well, the thing that this talk is really about is the answers in from a repertory grid analysis have several causes. And only one of those causes is the grid data. We get constraints on the grid. The size will make a difference. You can't really do principal components on a tiny grid. The kind of data in the grid, where there's been this, sort of shift towards rating scales from Kelly's original bipolar, but they're different kinds of data, and you can therefore do different things with them. And the real bane of the whole system is bipolar constructs. And then, of course, they're the constraints of the grid, and then it comes down to choices. We can choose how we transform the grid data. We can choose the method of analysis, and we can choose the criteria by which we decide this is of interest, this isn't. Well, what happens to grid data when we analyse it? We almost always transform it into something else, which we then analyse to something else. So we're not actually analysing the grid data anymore. We're analysing a different thing. So for example, we have grid data, transformed analysis, grid data, correlations, computer complexity coefficient. And this is quite away from that. What sort of transformations do we have? Well, if we're looking at seeing how the constructs relate to one another, or how the elements do, we usually transform them by distances or correlations. And we can then cluster them or put them into a principal component analysis. And if we do it jointly, we have to transform the data for both elements and constructs. So all of these things are going to produce different answers. So when you front up to the client afterwards, how do you know that what you're about to base your judgments on is not due to any of this? Just to elaborate, distances and correlations are the really big difference. There's the Mildred Shaw, Brian Gaines school that's very much into using a particular kind of distance, a city block or Manhattan distance. And what a distance does is tell you, if you look at the construct profiles across the elements, how far apart they are. But it doesn't say anything about whether the pattern matches, whereas correlations do exactly the opposite. If you want to say, do I have the same relative profile across constructs as my ideal does? A correlation will tell you that. A distance won't. Well, the choice will affect the representations of relationships among constructs and elements for both hierarchical clustering and factor analysis. The grid I'm using in this presentation is an Italian grid that I think Elena Faccio collected, translated into English, fortunately. And it's a 17-year-old eating disorder grid. Now, I should say, most people who work in the analysis of grid, they always have a grid in their book, which they use to demonstrate things. And that grid is always made up. And never works properly when you try other things on it. So I wanted to have an example that was actually what you'd find at the coalface. So here's classical construct clustering, sort of thing that Focus does, but they don't use complete linkage, they use single linkage. And you can see here, one of the things about this method is it splits it into two main groups and then it further divides them. So we could see that there's a line between them roughly in the middle, which is really, if you're a taxonomist, that's what you want to see. You don't want to see breaking off fragments. But if you look at city block distances, suddenly it's a very different picture. We've got one small group and one large group. And the question we should be asking is, which one is the right answer? And the answer is, we don't really know, but a paper Mark Hepman and I published a couple of years ago showed that some computer programs will actually do bootstrapping and tell you what's a significant cluster and what isn't. If we look at factor analysing, and a lot of people will say that correspondence analysis gives you the same answers as principal components. So correspondence analysis is the machinery of the grid core package, and principal component analysis of the widely used things is IdeoGrid, James Grice's American one. That one's free, that one's not. And you can see the answers are nothing like each other. So, and of course one of the reasons is correspondence analysis does that double wave scale pre-transformation. Both elements and constructs are transformed. Whereas principal components, here we've just collapsed across the elements to get construct correlations, but we get a different answer. Here is, well, can we put an ordinary raw grid into one of these analysis things? This is using the Mark Heckman's program, OpenRepGrid, which is on and off accessible on the web. And you can see here that this is a very distorted picture. Dimension 1 has got 83%, dimension 2 has got 8%, and we've got all the elements jammed down there, while the constructs are certainly differentiated. But you know, one doesn't want a picture with that sort of thing. Can we analyse just the raw data straight away? And the answer is yes. There's a few things we could do. We could calculate cognitive complexity from intra-class correlations. We can do some sorts of clustering of the data, and we can use a multi-dimensional scaling. The problem with all those is the famous bipolar construct. When we analyse these data, we have two sets of variables. One set of variable is the elements, and there's a point in the space for each element. One set of variables is the construct, and there's only one point in the space for that construct. But we've got two poles. And of course, it depends which way the poles are pointing. So the problem is,
what happens if you take it the other way around? If you point it the other way around, is there a general difference that emerges, or does it just?
It depends. How many are the wrong way round? That's a fairly crucial thing. never going to spot it. You cannot spot the orientation of the constructs from one of those sort of pictures. And it can lead us to trouble. There's no uniques. So we know when we transform, clustering's not going to give us a unique solution. All the different pre-scalings will give different component pictures. So, and then we look at the methods. The single linkage method is pretty well widely condemned in the general world of clustering outside PCP. But, sorry, yes. And unfortunately, that's a default in a couple of programs, such as WebGrid and GridSuite. You can't change that. Other programs, well, IdeoGrid doesn't have it. OpenRedGrid, you can change it. And of course, you can always use statistical packages like SPSS to do it. But if you use a different method, Ward's method is one of the ones regarded outside PCP, but you don't see it in PCP. And I've noticed that, I mean, my profession, I'm a psychometrician, not a grid person. You know, my PhD is in item response theory. So, you know, I think we should do it correctly. And of course, they all pick on me because they say, you're too fussy, you're too pedantic. But maybe it's because I actually understand what they're going to do, the wrong thing. Well, here's this problem with the bipolarity coming out to bite us. But you'll notice lots of diagrams put the two poles in. And the question is, where did it come from? And one of the problems is most of the programs won't tell you. And here is a WebGrid analysis of that grid. And the bit I want to focus on is down here. So I'll blow that up just a little bit. How do you decide which pole goes where? Well, if you look here, as I would like to be, is not very sensitive, fragile, problematic, undecided, weak. You know, I have the feeling that that's probably not true of the ideal person. But you know, hey, the computer program did it, it must be true. People say that sort of thing. So, IdeoGrid will allow you to flip the poles. But WebGrid is a closed system, you can't get out of it. Okay, can we just look at the grid? And there are people who say, let's just look at this grid. And I could see, you know, any clinician, when my wife was working, she was a clinician, you know, her eyes would just glaze over at a table of numbers, you know, and rightly so. But of course, pedantic people like me, the first thing I noticed was Elizabeth herself is always down one pole. It doesn't matter what the triad was. So I'm guessing that Elizabeth was always in the triads, and what she did was look for one of the other two to be like her. So it's kind of distorted, but what happens with a distortion, if you just look at it, you've got, this is how much data your ordinary non-quantitative clinician has to deal with. So there's 183 pieces of information in that. And I mean, that's about the size of a decent personality test, except with a decent personality test, we just add up the items in a pseudo-arbitrary fashion and get 5 scores to look at, not 183. So the problems with just looking at the grid is, the grid's actually displayed in an arbitrary fashion. The elements are ordered by the researcher. You know, you give them a list of role titles or something that you decide on. and the constructs are elicited in an order defined by the elements chosen. And of course, the polarity of each construct is a function of just those three elements that are in the thing. So if we go back to Elizabeth's grid, we've got this, and if we look at the ideal flips around a lot. So the actual positive pole, if we like to call it that, is flipping from side to side. And we need to find some way of finding the constructs that are out of kilter and changing it. So we've got to get the poles consistent with the general trend. Well, that's my way over. And then we need to reorder the rows and columns so like is next to like. So that, you know, we don't have quite so much. We don't have to look at the individual numbers anymore. We could just look at the way they're laid out. And a common approach to this is Thomas and Shaw's really old thing called focus. And I've quoted here from the online manual for the grid analysis program, the Spanish one, Record Grid Core, and it says, the main advantage of this procedure is the clarity with which any similarities appear without the aid of any graphic or mathematical support. I burst out laughing when I read that. Because what happens in focus is, first of all, you separate the elements and constructs. You then compute, well, no, the first thing they do is they put the constructs in twice, in one way, and then all of them in the other way. And then they decide that they'll pick one or other of the two. But to do that, then they calculate city block distances between each pair, and then they apply their single linkage analysis, which, as I showed, is not very good for clustering, but it's actually very good for ordering the rows and columns. So if you have a focused grid, don't look at that little cluster tree up the top. It's not very good, but at least you'll know that the rows and columns are in the right place. So this is what happens when we use the focus approach. And you can see the ones are basically up here, and the 6s and 7s are down here, and all of the positive poles are now on one side, instead of being flipped as they were before. You can do it other ways. You really do need to align the constructs if pretty well you're going to do any sort of analysis. I'm just trying to remember how long I've got. 10 minutes, right? So there's empirical ways you can do it, which I like, because that's the grid data talking, not the client's preferred thing, which was may depend on what they had for breakfast that morning. And using the ideal element is not too bad, except quite often you'll find the ideal element is not at a pole. Sometimes it's in the middle. And what does that mean? It means it's a dud construct, basically. But, you know, hey, you went to all that trouble to get the data, you're not going to throw it away. Whereas that method will deal with that problem. And then you reorder them. And if the constructs are aligned, you don't have to do all that fancy. You could just order them by the total scores. So that's just reordered by the total scores, which is sort of identical with a few minor perturbations to the focus method. Or, this is in open rep grid. Having done that, you can run a built-in filter on it and turn it into colours. And the colours are really helpful in seeing where the odd sevens are. There are some that are sticking out because they're quite out of place in that construct, and there are some where, you know, everybody's just about got one. Well, the other solution is to use summary methods. If there's 183 things in there, you know, can we get like personality test 5 scores or something? Can we use summary measures? Well, usually what you require for that is to find a total or an average or a median across the replications. So if you're looking at constructs, you treat elements as the replications to add up and divide or rank or whatever. So to get an idea of self-ideal similarity, we add the differences across the constructs, and therefore the constructs are replications. But of course, once we step into the world of replications, we've just collapsed our data, and that data that we spent, you know, an hour and 2/3 collecting, you know, we've now only got half of it left to think about. So that always struck me as, and if we're working out with some of them, it's even worse. Cognitive complexity gives me one number. How big does a grid have to be? And there's a person in here who asked me that question in a November workshop last year. And the question is, if you've only got 3, this is pretty well how reliable is any statistic. And I think this is actually for the standard deviation. So standard deviation based on 3 people is not worth the paper it's written on. 5 makes a huge difference. 10 is getting up near the asymptote. And of course, a lot of grids are around about 12, which is actually pretty good. So the raw data's okay. But, and there's different ways we can look at the summary. We can do it by grid, which is not exactly cognitive complexity, because that's a construct measure. I don't know if, I'm sure I could work one out and punish everybody by giving them the formula, but most things, when you get a measure for a grid, be it a self-discrepancy, a cognitive complexity, a measure of dilemmatic construing, it's summed across various things. And if we do within construct or element, we have the sorts of things we've looked at. And cognitive complexity, simplicity, we could say, okay, well, fair enough. I'm doing a dreadful thing to my data, compressing it right down to one number, but then the methodology question hasn't gone away. How do I do it? And we can form an intensity score, which is some kind of average correlation. We can get the variance associated with the first factor, PVAF, percentage variance accounted for by the first factor, and PCP is the only place in the world where that acronym is used. Everybody else thinks it's some kind of sewing machine or something. But then you have the problem, okay, first factor of what? If we do principal components, it'll be the first factor of correlations. If we do correspondence analysis, it will be from a singular value decomposition, which has got a totally different transformation on the data. Correspondence analysis does it by row and column totals, because it's actually a technique that was designed for frequency data. And intra-class correlation that I invented in 1980 actually is calculated from the raw grid data, but you do need to have the constructs aligned. So it's same for all the others. It depends how it's calculated. And what I was thinking of in this paper was more addressed to people using grids in an applied setting, mostly clinicians, but you also find organisational psychologists and educational people using them too. So you're really stuffed by this not knowing what has caused the answer. It's not so bad for research purposes because you make within group comparisons of the same method. You know, did cognitive complexity go down or up? You know, and you have a group average. But the only way you can do it in individual settings, I think, is it's okay with individual comparisons among constructs or among elements. But if you've only got, you know, the one grid. So, and it's not just confined to cognitive complexity. Here's the dilemmatic construct things. And there are 4 decision points that somebody, either the people who wrote the program or they've given you the options to choose something. And the answer you're going to get at the end is going to depend very much on those choices, whoever made them. So we're not actually talking about the grid quite often. One of the things that we don't do, and lots of programs calculate this, is really simple statistics. We flip over that page and the output to turn to the nice picture, when actually these are the things that are actually reliable. And as I say, it's widely ignored, although it's available. And of course, I mean, this is from my program, but you could do it in a number of others. And you can get, if you've got the constructs ordered correctly, the mean is meaningful because it tells you which end they're down mostly. So you get this one, strange construct, less hasty, simple, but way down one end or way down the other. And you can see how they vary. In fact, I haven't shown it here, but you could sort of say, okay, let me take the mean plus or minus 2 standard deviations, and anything outside that is really off the planet. We don't do it, but we could. So the advantage of these is it's based on the actual grid data. It can be pretty simple. It doesn't hurt to calculate the percentage of elements that fall at one pole or another. And one grid I analysed a few years ago, the interesting thing was that the self was always near the middle. The person couldn't decide where to put the self, you know. And the clinician thought that was quite helpful, but it was quite clear there in the table, you know. So you can use simple things. As I say, the difficulty is, how do we know what's a big and what's a small number? And that's true of all the summary statistics. Well, there's hope for the future. We can't use statistical things. Why not? Because statistical things depend on having reasonably large numbers that obey some theoretical distribution of random scores in that field. So you have to make an assumption of usually normal distribution. But if for some reason, you know, you valued our landfills, old outrageous statistics, which are very often more truly chi-square type statistics, which is not a normal distribution. But the hope is that and you know, I'm pleased I retired just as it became common, so I didn't really have to get on top of it, is what they call bootstrapping. You take the sample of numbers you've got and you repeatedly sample from that with replacement. So after you pick out a 7, you put it back and it's in there for the next draw. And you do that 1,000 times, 10,000 times. So you get the empirical distribution of your data and you can get standard errors. And it's totally common in SPSS now. Most of their statistics have a little box you can tick, you know, calculate bootstrap parameters and that. So, and as I say, Mark Heckman's program OpenRepGrid already uses something like that in cluster analysis. Unfortunately, Mark's not doing much work anymore because he's gone to work for Deutsche Bahn, who are not noted users of the regulatory grid, but they pay well. So, if we're looking at a clinician or anybody giving advice to one person or something, we have a problem. We've always got questionable validity, but we could always find questions to ask that the client would not obviously thought of. Now, conclusion, Kelly was right. The grid, you can really rely on a grid to give you questions. You can't rely on it to give you answers. Oh, what a pity, I've only left 2 minutes for questions. Yes? Luckily you didn't come to my paper in 1985.
Yes, I was very, very annoying last time when I posed my question to you. That was essentially real.
No, that was later, you know. You've dogged me all my life. Yes.
Are you familiar with the work of Peter Osorio?
Sorry?
Are you familiar with the work of Peter Osorio? He's not a psychometrician. He was criticizing psychometry and psychology.
No,
Okay. So he actually said that the real problem we have in our science is not on the data level, but on the meta level.
yes.
So how do you choose between correlation or discrepancies? Is there
Well, you
a
see,
meaningful way?
I mean,
Or is
the
it
advantage I have is that, and when students, and most, you know, I get students' data from kind of all over the world, and I say, why are you doing this? And they'd say things like, oh, I don't know, or, you know, it must be good, it's individual, you know, and so therefore it must tell us something, you know. Or the one I hate most is, my supervisor said I should.
You wouldn't get your PhD
So-
without it.
So, yes, it's, what I do is, of course, when they give me that and they say, oh, you know, I've got to get this written up by the end of October or something, and I say, don't worry, we'll find something. I know this is not the scientific method, but these poor devils, you know, they're going to have one nod at research in their clinical thesis, and then they'll move on to, you know, a real life, so to speak. So you can always find something. And what I do is, of course, when I say correlations and distances give you different answers, I just run multiple versions to see. And what I'm looking for is the structure that replicates across variations. Because then I think the only common thing was the original data. So, you know, if I get the same picture from correlations as I do from distances, I have some confidence that the artifact of the method has not impinged on it.
But if you get the different results and opposing results, then
Well, yes, there's, you know, all I can say is be careful, you know. Or just turn it into questions because, you know, it'll actually be more useful, as Kelly found. mean, we've got to stick to schedule, because if we get out now, by the time I come to do my last paper